My name is Georg Wittenburg. I'm co-founder and CEO of Inspirient. We use AI to automate data science. So thanks for the kind introduction. If I have to ask the obvious thing first, are there any data scientists in the room? 1, 2, 3, 4, a couple of them. So the first section is exclusively for you. We'll talk about business aspects and then maybe the more general aspects of this later on. But maybe just to begin with the very obvious. Yummy. Very yummy. But please, don't be alarmed. Data science has achieved some amazing things over the past decade. We're able to classify handwriting. We're able to read emotion from images, right? We're able to read emotion from tweets, from short text messages. We're even able to recognize threats or dangers in a moving vehicle, which in itself is amazing, right? Because you have a real-time situation in which decisions matter and can actually be deciding on almost life and death situations. So with all of this great progress that data science has made over the past decade, I myself stumbled over one thing beyond these 4 examples, which is this. So some of you might recognize this, some of you might not. When you open a file in a program like Microsoft Excel, and this is a data file that we would use on a daily basis, we'll ask you, well, you know, this data file that you have, is it delimited? Are the fields in the file separated by tab, semicolon, comma, or spaces? And at that point in time, you start to think about this, like, state of the art, like motions, handwriting, threats in real time. But asking us about, is this a comma or is it a tab? Like this does not make sense, right? So it's really strange. Like, have you ever wondered that you're faced in your daily endeavors with these kind of like trivial decisions to make, while at the same time working on data science or even artificial intelligence? So did I, about 4 years ago. And so I did the only thing that was kind of meaningful right then. I said, okay, let's build a classifier for my data files, which classifies whether this data is separated by a tab, semicolon, comma, or tab. And as you will undoubtedly understand, this was amazingly easy, right? And the accuracy of that classifier was amazingly high. It's not a difficult problem to build a classifier for. And that kind of got me into this rabbit hole of things, because you say, well, here's the first classifier. Let's classify the file format. Okay, done. Not that difficult. Can we classify the file structure? Like, can we say whether it is like a measurement over time? Can we say whether it's transaction? Maybe it's a P&L item from a business context. Maybe it has some location. Can we actually classify what the data is about? And it turns out, saying whether a data set is a time series is a classification problem. It's not a hard one. Like, you can do this. And we build that classifier. And when you do that, then you say, well, maybe if I know what the data set is about, maybe I can classify which analyses are applicable to it. Like, should I draw this on a map? Should I do this on a timescale? Should I draw this on a word cloud? Another classifier. If you got that, then you ask, well, there's certain patterns that you can detect in the data. Can you build a classifier that classifies which patterns are applicable, like which analysis methods are applicable to an analysis, and then can you say, can we detect the patterns? So we've been doing that for about 4 years now, and we've built 226 classifiers. And we believe that with 226 classifiers, you can actually automate quite a decent part of what is generally considered data science, like going from raw data, which might even be far messier than what I'm showing over here, to actually having something that you can put on the table. And this includes things like cleaning of input, doing a slicing and dicing of the data set, doing a time series analysis, doing a classification for patterns like segmentation, outliers, all these sort of things that you would say, yeah, this is what I as a data scientist spend my time on. You can actually build quite a good classifier for many of these. And in fact, it was in September last year that for the first time, at least in our company history, one of these automatically generated results was put in front of the board of a company. Say, okay, so this is an automatically generated result from an automated data science process that real board members actually talk about. That's interesting for data science because it kind of changes the role of what a data scientist will eventually end up doing. If you, as a data scientist, are putting things on a timeline, chances are that you won't be doing that 2 or 3 or 4 or 5 years from now. This is a workshop setting that we had about 2.5 years ago at Deutsche Bahn. The guys on the left and on the very right, those are data scientists. The 2 persons in the middle, those are the business stakeholders, the people that actually care about what's in the data, right? Everything that's on the table was generated by a computer. And these guys are having a conversation about what they care about, what could be conceivably correct or meaningful. It's interesting because it changes the process. All of a sudden, the business people have really, really easy access to say, well, this is something I care about. And the data scientists have really, really easy access to say, oh, that's good to know. Right? So real-world conversations that happened in this scenario include the following 2. Data scientist on the right-hand side said, very interesting problem that you're describing here. I'm afraid the data cannot deliver on that. And then when we were in the workshop, the business guy said, you know, the problem I had the other day, this thing over here is quite a good approximation. Can you add one more thing and then it will work for me? I said, oh, I didn't know you meant that. The other thing that happened in that very workshop is that the data scientist on the left said, oh, this is something that we've known for 2 years. And the business guy said, well, why didn't you ever tell me? It's really relevant for me, but you never told me. Right? All of a sudden, it's more a discussion about the results of the data science process as opposed to methods being used. Like, do we care about this? Do we know about this? That's interesting, right? So looking beyond the mere data science process in itself, so question to the audience, anyone from a more like business executive background in the audience? A couple of them, thank you. Okay, look, great. So if we now say, look, we've just learned that there's a technical process that can automate great parts of data science. That's interesting, right? Because one of the key problems that we see many businesses having right now is that it's not that they don't have any data, but the problem is to get value out of that data. And data is growing. It's growing about 40% per year. So you have more and more data, and you're still saying, okay, so what is the one needle in the haystack that I need to know about in order to, make a business decision? And it's not that you're not trying from the business point of view, right? So you're investing into big infrastructure, you're investing into data lakes, and say, like, this is what I want to build in order to get value out of my data. And here's the talk at Rise of AI that says that basically, like, all of these sort of things that are the end result of a data science process, so you say these are things that you would take into a meeting and have presented to you, can be automated. It kind of challenges the status quo a bit. So what's the first reaction from a business point of view that one would have to this? So here's one. This is a quote from a head of strategic planning at an automotive supplier about 2 years ago. He said, well, if this works, I can save the first 2 weeks of every McKinsey project. Right? He said, hey, I will just automate the initial analysis, have the initial results, and then have less to do for the people that are currently charging me a lot of money for this. That's one possible reaction. Another reaction that we also get very frequently is, my data quality is really, really bad. But once again, we talked about the state of the art in data science or artificial intelligence. This is a foggy street. Do you really believe that, for instance, your consolidated income statement has worse data quality than the image of a foggy street? A self-driving car will navigate that street, right? So it will work on that messy data and make decisions in real time about whether to turn left or right. So I think one of the key things for the business community is really to raise your expectation on what an analysis tool can do, even inside of lacking data quality. So, like the big trend here that we're looking at is essentially the trend of automation, right? So here's a process that you currently already have or plan to build, and that automation has a certain automation potential. Gartner says that they see an automation potential in data science for about 40% by 2020. And what it essentially does is that it says, hey, right now you have a decision to either put money, which is the y-axis, or time, which is the x-axis, against the process that you have, which says, okay, I got an outsourced team, I got an in-house team, and that's basically the cost-effective curve that I have in order to derive value from my data. What AI does here is that it just lowers the curve. It's an automation technology that allows you to run the existing process at a higher speed at a lower cost. But that's not all of it. So this is basically the thing that I delineated in the first part of the talk, which says, hey, you got a structured, repeatable way for getting from raw data to something that you would take into a meeting. But the key thing here is, as with so many AI systems, it really is fun if you have this sort of feedback loop. If you actually judge how good the result is. You say, yeah, like, thumbs up, thumbs down on the results that the system is providing, because then you can actually teach the system, or system can learn from your feedback what are the things that you care about in your data. And this is something that we actually do see in real-world settings. So this is an example from a case from last summer for an insurance company, in which a team of team leads, analysts, were looking at automatically generated results from their insurance data. And they said, well, we found something that we really care about. And they put these things together and say, okay, so maybe this is something that we should use for steering our business processes. But when it was eventually presented to a board member, they said, well, here's something else that I care about, which was not part of the things that you care about, right? So there's different pockets of knowledge, experience, and also business intuitions that reflect upon the data in different ways. People care about different things, and knowing who cares about which part in the data or in the results of the data is very meaningful, because then you can train the system and say, well, if I need a board-level presentation, maybe I show more of this. If I need something that's more operational, maybe it's more of these results. And if you have the feedback loop, then that's actually some pieces of data that you can gather from your ongoing operation. So, finally, who hasn't raised their hand so far? Lovely. So I know that some of you are basically here because you think AI is an exciting topic and thinking and wondering about the ramifications on society. Like, what's the impact of that? How will it affect all of us? And you've been sitting through the business side and the data science side of this talk, so let me tell you a joke. Here's a man kneeling on the street and saying, I'm looking for my quarter that I dropped. And the police officer says, did you drop it here? No, I dropped it 2 blocks down the street. Then why are you looking here? Because the light is better. And this is actually a psychological effect. This is an effect that's called the streetlight effect, which says humans intuitively search where it's easiest to search. Like, you don't crawl under the table unless you have to. You look at all the other places first, and only if someone tells you to, if there's no other choice, then you will crawl under the table and search there. And it's quite similar when you search for insights in your data. So this is a hypothetical landscape of data, right? And we know that in that landscape of data, there's all these interesting things that you could discover, but you need to know where to look. And there are certain constraints on you looking. Like, there's a time constraint if you're doing this professionally. You have maybe 2 days in order to find something, which means that you can't look everywhere, but you'll look at the places that are sort of most likely to yield a result that you have at the end of your project. So you selectively look at this data space and not comprehensively. And just to illustrate how real this is, this is a typical data set that the data scientist may analyze as part of his or her job. in fact, it's one of the most valuable data sets that I've seen in the past 5 years because it's the data from the United States Environmental Protection Agency in which they tested personal vehicles for their emission data. So this is a data set that has an inherent value if you know where the value is. If you don't know, then you just have a bit of data and you don't know where to start. So what the fact of automating the data science process really does is that it says, well, let me traverse the landscape of all the potential interesting sites and landmarks of that data set, and let me show the results for you. Here's one result. So this is derived automatically from the prior data set. This is a correlation analysis of NOx and CO2, which says that, here's a correlation, here's a bunch of outliers, and the outlier up here is the Volkswagen Touareg, right? If you don't know, if you haven't looked for that one, you won't find it. But if a system can automatically show this to you, that's good, right? Because then all of a sudden you've gained knowledge. And this is really a great thing about automating the data science process, is because it kind of allows you to push beyond human intuition. It says, here's usually I have an intuition about something that I might care about, and I have knowledge that I gain when exploring this. But there's actually more in the data. There's more in the data that you could potentially care about if you only knew about it. And now you have a structured process driven by AI that says, look, here are things that we can raise to your intuition that you can think about and then consider whether you would like to know more about it. And that's the true value add of this particular piece of AI. So the question really is, what will you find in your data? And these are my top 10 or top 8 actually from the last 3 years of doing business in this space. Will you find a network of fraudsters that are emptying bank accounts, as we did for top 10 international bank? Will you find abnormal spending of your external consultants that you hired, as we did in the data for a government agency? Will you find mishandled business loans, as we did for a top 3 German bank? I mentioned the outliers in vehicle emissions, but then there's also damage in German train station, underpaid employees actually, or that your IT cloud is actually located in the wrong country. The last one is my favorite. Someone discovered that their target audience of their online business is actually women. Right? And the last one is striking me as so very poignant in this, because it's not as if the question was difficult to ask, like are women our target audience of our business? It's just that these guys that are driving their online shop, they never asked the question. And they told us about that in the dinner, over dinner with also their investor present, and the investor was looking at them in disbelief and saying, I can't believe you never asked the question, right? Because it's obvious in hindsight, but at the time, these business people just didn't think about it. So, thank you very, very much for your attention. If you'd like to have a personal demo, we are right here around the corner in the dead center of the exhibition space, and we'd love to showcase how you can find new insights in your data using artificial intelligence. Thank you very much.
Okay, Georg, we have 6 more minutes left. So are there any questions in the audience right now? Okay, we have one over here in the first row. Teresa is coming. And then I saw a second one over there, but we will take you first, sir.
It might be very embarrassing because I arrived late, but what does it...
Hold on the microphone, because also the people in the back want to hear you.
It might be, thank you very much for the presentation, and my question might be very embarrassing because I arrived late, but it's very fascinating. What industries have you worked with, and where you see the biggest or the best applicability of your product?
Yeah, so in fact, because we are automating data science, there's no inherent tie to any particular industry. Like, everyone is trying to get value out of the data, and the process of doing so is not tied to an industry. We see most demand in industries that have a certain risk of not knowing things, right? So that's finance, that's audit, that's anything that's compliance related, but also factory floor data. When they say, hey, it's a certain risk of things breaking unless we detect them early enough. That's strange enough. We also have interest from the logistics area, which I can't quite explain, but maybe they have a certain innovation need given the entire mobility discussion. Yeah.
Okay, there was a second question over there in the back. A gentleman over there.
Hello, thank you for this great presentation. I'm a Six Sigma Master Black Belt, so I know how to treat data and look for patterns. But my question is, how would you convince me as a customer that you're giving me the answer I'm searching for? You know, you put the data there, you get an answer, and how should I know if it's for value for me?
So if I may answer in an analogy, if you're looking for a present for your wife or a loved one, how do you know it's the right present, right? You kind of know it when seeing it, right? So it's kind of hard to intuitively say, like, I don't know what the answer is, but I will recognize it when it's in front of me, right? And so basically, whereas in traditional data science, you have a hypothesis-driven approach. You say, well, we think about the business and the data that we have, and we believe that there's something interesting here, and then we go look for it. We challenge that assumption. What we're essentially saying is, have an open mind. Here are a bunch of things that are just factually in your data, which you can raise to your attention, and then we ask you to sort and prioritize pretty much in the same way that you would decide for a good present. You say, okay, so I got 3 alternatives, and this one seems to be the most relevant one, or the one with the most business impact, or the one that will make my manager most happy.
Okay. The gentleman over here had a question.
Yeah, thanks. A very interesting talk. I would like to have that. Open source, of course.
Of course.
Of course. What I didn't quite get is what's the AI part in the whole part? Because at least the first 3 steps you showed us, I imagine could be solvable with classical business logic and just pattern recognition.
Yep.
And then, of course, you talked about the feedback part. The feedback part now, standing people around the conference table talking about this is very laborious if you really want to have a lot of feedback circles. So are you already planning or maybe even have a ready-made system where data is delivered constantly and people can give feedback in a constant already made process?
Yes, and in fact that system exists right now, and you can try it in the exhibition area. I didn't focus so much on user interface issues in this talk, but in fact the system that we're building provides for that mechanism of providing thumbs up, thumbs down feedback to individual aspects of the analysis. So you have that closed feedback loop. And then as for the first part of your question, the thing that we are building is a very pragmatic way of doing it, right? So if there's a classifier that we can build through pure business logic, right? So for instance, like the initial example that I gave for classifying data files, that's not a neural network, right? And it shouldn't be a neural network because it would just be like, too much. However, there are certain parts in that process, especially when classifying the semantics of data. For instance, is this a postcode? Is this a currency value? Is this a location? Is this a human name? Is this a city space? There's all kind of like little steps that you need in the data science process in order to drive to the semantically correct conclusion, and that's actually something where we use, let's say, more advanced techniques from artificial intelligence to build the relevant classifiers.
Okay, one more question was in the back, I saw it. Yeah, you.
I have a question. So what's your prediction of population of data scientists in 5 years? It's going to decline or increase?
So I think we are very much in a transitionary phase, right? So like there's this new, going on for the past, I would say, between 5 to 10 years, phase on how business is being digitized, and data science is a great part of that. As with any new profession, once you passed the initial phase of it, people will start to worry about cost. They will start about efficiency and also about repeatability of the process, right? From the point of view of AI, we're not trying to solve data science in its entirety, but we're saying data science is an 80-20 process. It has a good proportion that can be automated and a good proportion that needs specialized expertise and skills that just doesn't make sense to put into an AI system. So with that in mind, I think that the population of data scientists will actually be growing because there's just so much data to analyze. However, I think that the focus of their work will change. They will change from doing the, let's almost say, trivial things, at least the things that can be automated, towards communicating about these things with their business counterparts, and then actually doing the deep dives that follow from that. Whereas if you have a data scientist, even right now, that is busy doing a time series analysis, consider the alternatives, please.